I am Dr.G.B.Chandra Mouli, Assistant Professor of Mathematics, Freshman Engineering Department, Aditya University. Now, we will see another application of first order differential equations, which is electrical circuits. Learning outcomes. At the end of this lecture, student will be able to find current in an electrical circuit, which is RL circuit. So, before seeing the RL circuit, so we will discuss electrical circuits in general. So, the formation of differential equation for an electric circuit depends upon the following laws. Let I be the current and Q the charge in the condenser plate at any time t. So, we have taken an inductor with the inductance L, a capacitor with capacitance C, and a resistor with resistance R, and V is the voltage. So, I is the current which flows in this series circuit. So, it is a circuit containing an inductor, capacitor and resistor. So, then I, the current I is given by rate of change of charge, which is dq by dt, or q is equal to integration of I dt, and applying the laws, voltage drop across the resistor R is given by Ri. So, here the voltage drop is proportional to the current I, and V is equal to, or voltage drop across the resistor with resistance R is given by Ri, where R is the proportionality constant here, and voltage drop across inductance L is given by L di by dt, or because I is dq by dt, it is also represented as L d square q by dt square. So, here in this the voltage drop is proportional to di by dt. So, V is equal to L into di by dt. So, L is the inductance here, and voltage drop across capacitance C is given by Q by C. So, there will be voltage drop across the resistor, inductor and capacitor, which are given by this, by the laws as mentioned. Now, the famous Kirchhoff's voltage law. The algebraic sum of voltage drops in each part of any electrical circuit is equal to the resultant electromotive force in that circuit. So, using this law, we form the first order differential equation, which is associated with the circuit, electric circuit. Now, as a particular case, we consider the electric circuit with only resistor and inductor. So, which means that the circuit can be taken as RL circuit. So, for this RL circuit, what is the differential equation which is associated with the circuit, and what type of differential equation is that, and how to solve that equation. So, here whenever R and L change in the circuit, obviously the resultant, which is the current, will change, and that will give an idea about the current in the circuit. Now, for this RL circuit, let I represent the current flowing in the circuit containing resistance R and inductance L in series with voltage source E at any time t. Then, by Kirchhoff's voltage law, so this left hand side is the algebraic sum of the voltage drops across the inductor and the resistor. So, voltage drop across the inductor is L di by dt, and voltage drop across the resistor is Ri. So, the sum is L di by dt plus Ri is equal to the resultant electromotive force, which is E in the circuit. So, L di by dt plus Ri is equal to E is the equation corresponding to this RL circuit, and we can rewrite the equation in the form L di by dt plus R by L into I is equal to E by L. So, this is again a standard form of a first order differential equation, which is linear differential equation in I. So, I is the dependent variable in this, the current I, and it is a linear differential equation in I, and we know how to solve the linear differential equation. So, after writing the standard form of the linear equation, so we have to find the integrating factor and then the general solution of the linear equation. So, corresponding to this RL circuit, we have a first order linear differential equation in I. Now, we will see an example which contains RL circuit. A generator having EMF 100 volts is connected in series with 10 ohm resistance and an inductor of 2 henries. If the switch is closed at time t is equal to 0, then find the current at any time t greater than 0. So, we have to find the current in the circuit for the given values of R and L, R, L and E. Now, the solution. Now, the differential equation corresponding to this RL circuit, as we have seen from the Kirchhoff's voltage law, is di by dt plus R by L into I is equal to E by L. And from the given question, we have E is equal to 100 volts EMF, and resistance R is equal to 10 ohms, and inductance L is equal to 2 henries, and it is given that the switch is closed, which is given by this condition. The switch is closed at time t is equal to 0, which means that at time t is equal to 0, the current I is equal to 0. So, I is 0 when t at t is equal to 0. So, this is the condition given in the question. Now, we substitute R, L and E values in equation 1. So, di by dt plus 10 by 2 into I is equal to 100 by 2, and simplifying this, di by dt plus 5I is equal to 50. So, this is the first order linear differential equation in I, and for the solution we find the integrating factor as e power integral 5 dt. So, 5 is the coefficient of I, which we have to integrate here, e power integral 5 dt. So, it is e power 5t. So, here t is the independent variable and I is the dependent variable. Now, the general solution of equation 2 is, so the dependent variable I into integrating factor is equal to integral this right hand side of 2, which is 50, and integrating factor dt plus c. So, substitute the integrating factor as e power 5t on both the sides. Now, on the right hand side we have integration of e power 5t. So, I into e power 5t is equal to 50, okay, e power 5t dt plus c, where the integration of e power 5t will give you e power 5t divided by 5. Again, simplifying this, I e power 5t is equal to 10 e power 5t plus c. So, this is the general solution which represents I. Now, at t is equal to 0, I is 0, this is the initial condition in the problem. So, we substitute these values in 3. So, I is 0 and t is 0, e power 5 into 0 is equal to 10 into e power 5 into 0 plus c. So, this will give you the value of c, which is minus 10. So, c is equal to minus 10. So, substitute c is equal to minus 10 in the general solution. So, this will give you I into e power 5t is equal to 10 into e power 5t minus 10. This is a correction. So, it is minus 10, or this can be represented as I is equal to 10 minus 10 into e power minus 5t. So, for given values of t greater than 0, we can identify the current in the circuit. So, I is equal to 10 minus 10 into e power minus 5t is the current in the circuit for t greater than 0. So, we can identify the current in the circuit for different values of R, L and E, okay, in the RL circuit. So, one more example. So, if a voltage of 20 cos 5t, so this is the EMF in the circuit, is applied to a series circuit consisting of 10 ohms resistor and 2 Henry's inductor, then determine the current at any time t. So, we have to find I in the circuit for different values of E, this is R and this is L. So, it is clearly an RL circuit, the circuit is containing a resistor and an inductor. So, we write the differential equation corresponding to this RL circuit. So, the first order differential equation which is obtained from the Kirchhoff's voltage law is di by dt plus R by L into I is equal to E by L. So, given E is equal to 20 cos 5t, R is equal to 10 and L is equal to 2. Substitute these values in equation 1. So, we will get di by dt plus 10 by 2 into I is equal to 20 cos 5t divided by 2. One simplification we will get di by dt plus 5i is equal to 10 cos 5t. So, this is standard form of linear equation in I. So, for the solution we find the integrating factor as e power integral 5 dt. So, which is e power 5t. And the general solution of equation 2 is the dependent variable I into integrating factor is equal to the right hand side of equation 2, which is 10 into cos 5t multiplied with if integrated with respect to t plus c, because t is the independent variable. So, we have to integrate cos 5t into e power 5t, because e power 5t is the integrating factor. So, I into e power 5t is equal to integral 10 cos 5t e power 5t dt plus c. So, we have a standard integration here, that is integration of e power ax cos bx. So, from this which gives you e power ax by a square plus b square into a cos bx plus b sin bx. So, using this integration formula, so we integrate cos 5t e power 5t dt. So, e power 5t by 5 square plus 5 square, because both these coefficients are 5 here. So, 5 into cos 5t plus 5 into sin 5t. So, this will give you, this is 50. So, I into e power 5t is equal to e power 5t by 5 cos 5t plus 5 sin 5t plus c, or dividing by e power 5t on both the sides, we will get the current in the circuit as I is equal to 1 by 5 into 5 cos 5t plus 5 sin plus 5t plus c into e power minus 5t. So, c is an arbitrary constant in this solution. So, this is the current in the circuit for any t greater than 0. So, in this manner we can find the current in electrical circuit, RL circuit. So, given the resistance R, inductance L and EMF E. So, the circuit is modeled using Kirchhoff's voltage law and it will represent, so the equation by voltage law, a first order differential equation as di by dt plus R by L into I is equal to E by L. So, this is the differential equation corresponding to the RL circuit, and solving this equation we can find current in the circuit at any time t greater than 0. Thank you.